Good evening, ladies and gentlemen. My name is Mduduzi Mnganga, team member of team number 13 for a project in the application of numerical methods in civil engineering. This report is prepared by the APM 3715 students, team number 13, to discuss the approach and give insight into some of the aspects relating to the use of numerical methods in solving civil engineering problems. The team formulated their own broadly defined civil engineering problem, then worked together to provide the solution for the chosen problem using the numerical method analysis with the aid of a programming software. Details of the problem and level of complexity. The project entails the calculation of quantities for mass earthworks of a water pond. The task was to calculate the cut and fill quantities of the water pond using the numerical method, namely trapezoidal Simpson rule, and furthermore, same exercises was done using GNU Octave and other online software such as A2Z Met, Core, and the EMET help. The results for both numerical methods and the GNU Octave were used to calculate the absolute and relative error. Analysis of the problem. There are various methods to which the problem can be solved. The team performed these calculations by using two methods. The result proved to be similar and will be discussed in the next section. One method is to divide the pond into 5-meter wide sections horizontal as indicated. And as for myself, Mduduzi Mnganga, I have went on a vertical direction of the pond to just confirm if the areas will still give you the same volumes required. The cross-sectional areas of each section is then multiplied by 5 meters to obtain the volume of each section. The sections are then being summed up, resulting in the total area of the pond. A second method is to divide the pond into 5-meter sections vertically, as indicated with the Simpson rule was applied, and the total volume is then calculated similar to the first method. Calculations are done in both Excel and GNU Octave, and a comparison of the answers are provided together with the comparison or to check the calculating of the absolute error and the relative error. In terms of the approximation using the trapezoidal rule, we have Mr. Dean Walker, who has managed to complete the Octave, the trapezoidal rule in Octave for us, and he has completed each section of the pond, each cross section of the pond, and provided the answers for it. And second, took another section. Then Mr. Tato also did the appraisal via the Open Electronic Resource Tool with EMET help, where we've got also the solutions for it. Then Mr. Mduduzi Mnganga, myself, also completed the program or the problem using the Simpson rule And in using the Simpson rule application, I also noticed that most of the time we have looked at the formula as a very strange formula, but it is a very easy formula to work on. In terms of calculating the areas, we have used in terms of the distance between the points that we have taken. That distance becomes our h, which becomes now 5 meter, and that 5 meter is divided by 3 and multiplied by y, which is our first y plus the last y plus the 2 times the sum of the odd numbers or odd points that we have on our solution, and we add also 4 times the sum of the even numbers, and we've worked out the total area for that, and took all the 9 sections that we have under Simpson rule, and the trapezoidal which we used 8 sections to work out the total volume of or the total areas plus the total volumes of the cut material that needs to be removed from the point. In comparison of the two results, it is noticed that in the trapezoidal model or mode, we have achieved the volume of 1,677 cubic meters, and under the Simpson rule, we managed to get 1,679 cubic meters. The team completed the exercise and presented the solutions. Based on the findings, the teams compared the various solutions, which gave almost the same answers, and therefore appraisal of the solutions in all methods is accepted by Team 13. I've also picked up that, in conclusion, the team has used the advantage of available technologies to convene meetings under challenging circumstances, from the current prevailing load shedding of power supply to the country, without fear of meeting these objectives for the project. We applaud the effort made by the team and the team contribution to make this project a success. Thank you.